Okay. All right. Sorry about that, everybody. Internet's being a little wonky. So, uh, apologies about that, everybody. Okay. Hopefully my internet will stop being wonky and maintain its connection without too much trouble. All right, hopefully. Anyway. Okay. So, let's take a good look here at our question one more time. A worker earns $28.50 per hour. She receives a 7.5% pay raise. What's the amount of her hourly raise? All right. So, if she makes $28.50 per hour and she receives a 7.5% pay raise, all we'll need to do here simply is figure out what 7.5% of 28.50 is going to be. So we want 7.5% of 28.50. Now, what is important here is that if we want to figure out what 7.5% of 28.50 is going to be, I want to talk about one very important thing here in a problem like this, okay? And that's this. One of the keys here in a problem like this is that you should convert your percentages into decimals, all right? So if we're going to do calculations here, all the percentages that we typically use for the most part will be converted into decimals. So if we look at 7.5% here, okay, then what's the decimal equivalent of 7.5%? Okay, good. That's right. So we're going to take 0.075. And we're going to take that and we're going to multiply it since we have the word of. Again, multiply that by 28.5 or 28.50 for the amount of money that she currently makes. And what do we get here if we multiply that? So again, you can bip bop boop in the calculator there. Anybody got an answer for me? Okay, it's fine. $2.14. All right, seems fair. So a nice raise of $2.14 here per hour to add to the collection. All right, good stuff. So not too hard, but there you go. Nice and straightforward. All right, questions about that so far? No? Okay. Let's try another one. Uh, there was a problem here that I... Okay. Yeah, there's two more I want to do here because it's some of the problems here are a little tricky. So, okay, so this one's a bit tricky, so this one we'll talk about. Number 12. Jiffy Print needs to produce 4,000 error-free copies of a brochure. For this type of run, there is usually a 2% spoilage rate. What is the minimum number of brochures that should be printed to ensure 4,000 good copies? All right, so what do we what should we get here in this case? We want to ensure that we get 4,000 good copies here with a 2% spoilage rate. How do we get that to happen? Let me check something here. Okay. 4,000 times 0.02. All right. And what's 4,000 times 0.02 here? Then it should be 80. Okay, that's correct. All right, so that should be 80 in that case. Now, the answer would be 4,080. That's right. Now, there is another interpretation to this. Okay, and this is why this can be a bit tricky. The answer pretty much is like 80. It could be 80 or 81. And let me go ahead and discuss this problem here, because this problem here actually, again, you can look at it from two different directions. So if we want 4,000 error-free copies here, okay, and we have a 2% spoilage rate, that means that 2% of the copies that we make should be thrown away, okay? So we should have like a whole bunch of copies minus 2% of those copies somehow should equal 4,000 good copies. So if I were to do it algebraically, and then we would have, say, x, which would be like the x amount of copies that we would need, minus 2% of those x amount of copies. Okay, so minus 2%, which is 0.02, of those x amount of copies somehow needs to equal 4,000, which should be the good amount of copies. Now, in this particular case, if you were actually to do like terms here, which we'll discuss in Chapter 6, then we'll do 1 minus 0.02, and you actually get 0.98, 98%, would equal 4,000. Then you could divide by 0.98 on both sides, again, just using our algebraic principle of balance. And so here we get x is equal to, and if you actually do this on the calculator here, you will get, of course, a decimal answer. That part, yes. But here you actually get 4,081.63. So in fact, yeah, approximately, if you round up here, you get 4,082. So that again, there's a couple of ways to kind of interpret this type of problem here. One is with algebra, and one is, so you say like 80 is pretty close, you know, but if you look at it this way, you're like, oh, maybe those 2 extra copies could make a difference. Okay, so just got to be careful about the wording there in a problem like that. Oops, bring that back up again. Okay, any questions about that? All right. All right, now there's one more that I would like to do here from this section, and we'll move on to the last section there of the thing. Okay. All right. So let's take a good look at this one right here. So an independent mechanic purchases parts from her distributor at a 20% discount from the retail price. She then makes part of her profit on the repair job by charging her customer 15% more than the retail price. If the 20% discounted price for a set of brake pads was $75.20, what is the price the mechanic will charge her customer? Okay. So let's take a gander here. Let's see how this goes. All right. Excuse me. Okay. So at first, if basically to do this problem here, we're going to go in logical order. I.e., she's going to purchase her part here from the distributor at a 20% discount of the retail price. So what we'll do here in this particular problem is we're going to go ahead and put in a 20% discount from the retail price. So X is going to be our retail price. Okay. We don't know how much the retail price is going to be, but what we do know is that the 20% discounted price for a set of brake pads was $75.20. So if we do know that, then we do know exactly how discounts work. Again, we take the original retail price minus the discount, and then that will get us our sale price there. So let me put that in the actual Word document here. So again, one of the things is a sale price, which is equal to the original price minus the discount, aka this equals the original price minus the percent off in decimal times the original price. Okay, so this is how we can figure out a sale price here. And if we talk about a markup again, like what a retailer would sell it to you at, since they want to make some kind of profit, then it's going to be the original price plus the markup. So again, this will be the original price plus the percent markup in decimal times the original price. The only difference between these two formulas here is just that sale price is subtraction, markup is addition. Okay, which is, well, honestly speaking, pretty easy in that regard. Okay, but we have X here being our retail price. That's going to be our original price there. So we have X minus, and in this case here, we have 20% off. So 20% here is going to be 0.20 for 20% times X. Again, that's the original or retail price in this instance. And that's going to equal, how much we have here? $75.20. So now what we want to do here is we can combine these x's together using some simple like terms. So we're going to do one 1 because this is 1x. We do 1 minus 0.20. What is 1 minus 0.20? What's that? All right, 0.80. All right, good. So we're going to have 0.80 x equals 7520. Okay. And then we're just going to divide by 0.80 on both sides, again, just like we did before in the other problems. And can anybody give me an answer here? What's x equal to here? All right, $94. Okay, so the part's original retail price was 94 bucks. But now that we have the $94, she's going to charge a 15% markup to the customer. Okay, so all we're going to do here is we're going to take the $94 we just found. That's the markup here, the original price, plus 15% markup, which is 0.15, times the 94. And what do we get here in this case?